Welcome! This is now the feedback to the fourth week of GeoMOOC 2017. This was dedicated to sediments and especially how they are deposited in the marine domain. And now I want to take the occasion to highlight a couple of important features. We've seen the effect of sea level changes over sedimentation patterns. This is something which happens globally as a result of climate changes or a number of other factors. So these affect the entire Earth in a comparable manner. These are what we call allocyclic, allogenic patterns, patterns which influence a sedimentary succession from outside. Factors which have a role from inside the system are called autogenic. So these are situations which shape these sedimentary bodies from inside. The balance between the two is always complicated. How much is the influence of climate and how much is the influence of local factors? You see, for instance, this beautiful outcrop is a beautiful cliff near Asaka. This is in northern Morocco, and you see a nice mountain going towards the Atlantic Ocean, and you see in the lower part soft shales, and then there is a body of sand coming into the system here, which passes then afterwards to more shales. Now, why do we have these sands? Why do they have this thickness? Is this a question of sea level change, or is it a question of a river arriving in this area here? Some of you asked also more information about coasts, and coastal shapes are also resulting from the interaction of autogenic features such as currents and tides. Now, here is a diagram showing three different types of tides. On the left-hand side, you see a coast dominated by waves, and it's characterized by linear features like these sand barriers. When we have stronger tides, then there is more water movement across these bays, and then the bars tend to be destroyed, and we have more features which are elongated perpendicular to the coastline, in contraposition with the wave-dominated tides areas where the coast is characterized by long elongated features. I think the deep marine domain is a very interesting domain for sedimentological purposes, especially because we tend to think as the abyssal plain as a place where nothing happens. Now, this is not the case. If you look, for instance, in this picture here, this is a seismic picture, a seismic attributes picture of deep into the coast of Western Africa. And you see shapes which really remember very closely the shape of meandering rivers. But this is produced by turbidity currents deep at maybe 2,000 meters, 3,000 meters water depth. Turbidity currents, I think, are one of the most fascinating geological features. And you see how regular they can be. You see that in this outcrop, each of these layers is a turbiditic event, which is really straight and with no erosion, with absolutely constant thickness. This gives you an idea of how these turbidity currents that arrive in the abyssal plain, they expand and covering with sediments a very deep surface. One of the features which was mentioned in the feedback is the CCD, which is carbonate compensation depth, which is the depth under which no carbonates are found. What happens is that there is organisms, plants and animals living in the uppermost part of the water column. They die and they tend to sink down. Because the solubility of carbonates depends on temperature, and the colder the water, the higher the solubility, these organisms will tend to dissolve when they reach waters with a lower temperature. And then you have the CCD, which is kind of comparable with the snow line. The snow line in the mountains depends on temperature, obviously, but also depends on the amount of snow which is precipitating. In this case, it's a similar situation. If we have cold temperatures and we have a lot of production, then we can get a CCD like this. If there where the seafloor is higher than CCD, we will find carbon-rich sediments. In parts of the seafloor which lie underneath, deeper than the CCD, sediments here will have no carbonates and will be dominated by silica. Thank you very much, and we'll see you next week.